Hello, this is identifying malicious activity and network traffic for Data 670 Data Analytics under Professor John McKeeby. The real problem that we're trying to address here is how do we identify malicious attacks within network traffic. Most network traffic is actually going to be benign. Most network traffic is just going to be normal everyday users doing normal everyday things, shopping, browsing, looking at YouTube videos, things of that nature. However, when we do identify malicious attacks within the network, we want to be able to first identify it, and then two, shut it down, and then three, be able to prevent it in the future. We want to be able to restructure our network so that it can handle these attacks a lot better. If one of these attacks becomes successful and we do receive something like a denial of service attack where users can't connect to the information that they need or to the products that they want, then that could result in the loss of thousands, millions of dollars of potential revenue that we could be just simply losing. One such example of this would be in Vegas right now, or in Caesar's Palace, where they are indeed losing millions of dollars a day to a group of hackers that have successfully shut down the establishment. Really, the problem can be defined and separated into three parts. First of all, we have real-time detection. We want to be efficiently identifying malicious network traffic and essentially analyze the network data so that we can respond to the threats in real time. And so this is really crucial for minimizing the impact that the attacks have on our network. We want to be able to maintain a solid network that has very few interruptions and that services the users within the company. Now, on top of that, we want false positive reduction. Speaking about reducing the interruptions to users, we ourselves do not want to sort of overcorrect and sort of intrude on the experience of users. When we go ahead and flag malicious activity, that is potentially benign. We might be interrupting people from their everyday activities. We need to be able to balance the need to detect malicious traffic while minimizing the false positives. A successful solution should really reduce the false alarms, ensuring that legitimate network activities are not mistakenly flagged as malicious, which can, strain resources and create unnecessary disruptions to our user base. Finally, we have adaptive solutions and strategies. The problem with identifying malicious traffic is it involves not only the detection, but also the development of an adaptive strategy to go ahead and combat this. These strategies should be really capable and should be able to respond to the detected threats dynamically, potentially including actions like blocking, especially isolating the compromised devices and the compromised traffic. Well, first of all, we want to give some background into the information of the original set. Next, we want to see what gaps lie in the research that has already been collected. So the steps would be, what is the origin of the set, the refinement of the set, and then finally, what are some of the machine learning models that have already been created using the R programming language. So what is the origin of the set? The motivation behind the set was a response really for a lack of a comprehensive intrusion detection data set. There have been many other sets before this with network connection that went ahead and collected data based upon that, but there wasn't a really comprehensive, all-inclusive data set in regards to that. So what this is that it's a combination of benign and malicious network activity generated over 5 days, and it simulates DOS, DDoS, brute force, XSS, SQL injection, infiltration, port scanning, and botnet. There are other types of attacks that are sub-queries or sub-divisions of this, of these types of attacks, but then we'll go over them in detail in the later segments of the presentation. So refinement and analysis of the dataset. So essentially what happened is that in 2018, refinement of the set came to be because of how unkempt the data was. This leads more into the data preparation stage, and the cleaning of the data. But essentially, there's a huge volume of missing values, a huge volume size, and a high class imbalance. This was really resolved by mainly combining similar classes to sort of reduce the imbalance and improve the accuracy of the actual data set. However, later on, when we actually get to take a look at the data itself, we'll go ahead and see how the data is shaped and what kind of problems that we're going to be facing when we actually go ahead and tackle this data. Finally, there comes the paper regarding machine learning using the R programming language. There were two utilizations of the R programming language to go ahead and create models for determining malicious attacks on our network. The first one was utilization of an artificial neural network, and then the second one was a machine learning algorithm. We will be using both. Instead, we're going to be using Python along with adapting and improving upon the machine learning algorithms that were used inside of R. So reiterating again, what we're going to be doing is we're going to be combining the new way of visualizing and utilizing the data set, essentially. And we're going to be also utilizing the machine learning algorithms and then putting them into Python instead, so that we have a better use of visualization tools, such as with PyPlot, and we have a better understanding, or we have better accuracy, potential better accuracy with the refined data set. So as a reiteration on the importance of the project, the four things that we're going to be focusing on are the reduced business disruption, cost savings and risk reduction, enhanced network security, and compliance with regulatory requirements. Timely detection of network attacks through the project using this data set can really significantly reduce business disruption by swiftly identifying and mitigating the threats that are present in our network security. Organizations can maintain operational continuity, minimize downtime, and really prevent financial losses associated with the service interruptions. Cost savings such as that, cost savings and risk reduction, detecting and mitigating these network attacks proactively can really result in cost savings over the course of time. The minimization of the financial impact of cyber attacks can really start to add up. More so, not necessarily just because of our service that we're providing to our users, but also to the reputation that we have with our users. Next is enhanced network security. Projects that are based on this data set and on this model can really enhance their security by developing effective intrusion detection systems using this data set. Organizations can better protect their networks from a wide range of attacks, including DOS, DDoS, intrusion attempts, and then in turn, this really will help safeguard our sensitive data and ensure that our customers are having the best experience that they possibly can, and then we have business continuity, and we really maintain the trust of the customers and stakeholders as a whole. Now, compliance and regulatory requirements that we have. So projects that are focusing on network attack and detection using this data set are really instrumental in helping organizations meet compliance and regulatory standards. Many industries have stringent data protection and cybersecurity regulations. Implementing effective intrusion detection systems can really demonstrate compliance and avoid legal penalties, and also maintain the trust of regulatory bodies that are also part of this. Some key performance indicators that I've set out for myself regarding this project is 1, to complete the assignments in a timely manner based upon the new trajectory of this project. Number 2, successfully create a model to differentiate between benign and attack activity. And then finally, number 3 is to successfully create a model to differentiate the type of attack being performed on the network. So what does this mean? Not only do we want to create models to differentiate between what is an attack and what is not an attack, but also we want to create a model that differentiates the type of attack. What kind of attack are we experiencing? And then because of that, that'll allow us to further understand and develop a specific type of fix for the type of attack. So what is this data set? Well, this data set is the CIDS 2017 data set. What it is, it's a comprehensive data set that's widely used for evaluating intrusion detective systems, or IDS for short. It comprises a diverse range of network traffic data, including both benign and various types of network attacks. It's a realistic representation of network activity. The dataset offers realistic portrayal of network activity, including the genuine workflows, the attack scenarios, and it covers a wide variety of network protocols, communication patterns, and attack categories. It really makes itself suitable for testing and benchmarking intrusion detection within the real-world strategies. It's a really large scale and a high dimensional data set with millions of network record flows. It really makes it suitable for testing machine learning and deep learning models and includes a variety of multitude of features. It's one set essentially, or it's a variety of different sets. It's one set with various subsets. 8 subsets ranging in size from 170,000 rows to 692,000 rows, with a total of 2.8 million rows of data with 79 features. So with over 2.8 million rows, what does this data look like? Well, there are 15 class labels, 1 basis, and then 14 attack, and then 79 features. So essentially what this can be comprised of is one label regarding what type of attack it is, or whether or not it's benign, and then 79 features regarding the actual network traffic. So we have the destination port, we have flow duration, total forward packets, total backward packets, etc., and then finally the label. So what does this mean? Well, we have on the left, on the right hand side, we have the label in regards to benign, the bot attack, DDoS attack, DOS GoldenEye attack, DOS Hawk attack, and we have the variety, or we have the number of instances that this attack is occurring, right? So 83% of the actual total data that's in this data set is going to be benign. Most of it is normal, regular activity that happens on pretty much a daily basis. And then the rest of it, right, gets separated down into the different types of attacks. Now, most of it is going to be concentrated in the DOS, the denial of service Hawk attack. However, most other attacks have very, very, very little contribution to them. For instance, SQL injection attack, out of over 2.8 million rows, there are only 21 instances of a SQL injection web attack. So these are things that we're going to have to sort of group together and then figure out, and that's also what's going to be happening in the data cleaning phase and the data rearranging phase, when we're going to have essentially to squish some of these together so that we can combat the high variability in classes. So lessons learned here, lessons learned. For how large the data set there is, there's a very, very limited number of attack cases, relatively. You know, with 83% of the data set being benign attacks, 13% of it is only, or sorry, 17% of it is only going to be the actual attacks. Now, for a man-made generated data set that simulates real-world activity, this is very, very low in my opinion. So even though there's a lot of data here, there's a very low percentage, relatively, in regards to how much data there is, especially for the amount of attacks, for the specialized attacks. Like we saw in the previous slide, it was 21 attacks in total for a SQL injection attack. Now, the second thing is that there's a large amount of inconsistency in class variability. Just like I said, only 21 SQL injection attacks. These can obviously be grouped together and then combined later on, but in the data cleaning phase, that's what we're going to have to focus on. So on to next steps. Well, first of all, we need to build upon the research, redefined data set, and provide more accurate predictions based upon that redefined data set. We need to combine certain attacks together so that we can have less class variability and we can have a better prediction of the actual, or a better prediction for this model itself. Next, we have to refine, redefine current predictions and models that were used in the R model and incorporate them into Python and then build a better one. And then 3, we have to utilize Tableau to build better and more interactive data visualizations. Here are the references used for those data sets, for those papers, and then finally, are there questions to be asked here?